Assalamu alaikum, Bismillahirrahmanirrahim. Welcome to our JNCIS, that means Service Provider Routing and Switching Specialist course. We're discussing MPLS fundamentals. In MPLS fundamental modules, there is multiple module. Last day, we have discussed module 8, RSVP, LSP bandwidth reservation. Today we discuss RSVP, LSP priorities. Okay, how to prioritize LSP. We can show you today how to configure this. Okay, let's start. So this is our today's slides. RSVP, LSP priorities. There is total 7 section, including lab. Okay, so we will discuss one by one. Let's start. The first section is the problem with RSVP bandwidth reservations. So there is the some terminology and acronym which is used in MPLS backbone or related to MPLS technology. Okay, so see the topology. This is the same topology which is used for MPLS testing. And see here, a put it up first. I get the peak of the links for my LSP. I put it up last. My LSP have less path options. That means RSVP bandwidth. The first LSP get the best path. First LSP gets the best path. Second LSP will get less specific or good or worse path like this. Okay, so does it matter what order LSP come up in? That means you are just making multiple LSP from one ingress to another egress router. So you need to prioritize some LSP. So how to prioritize this? This is our today's topics, how to prioritize the LSP. Yes, so say the router 1 to router 5 creating the YOLO LSP. Another LSP is creating from router 1 to router 4 via router 6. There is two different LSP and there is bandwidth reservation is happened, and you need to prioritize the LSP. Okay, so this is our usual case. There is no priorities. There is a default priorities in a default configuration. So now we're in question and answer section. Number one question is, so what is the possibility of the metrically based path not being able to offer the required bandwidth? The correct answer is when the router boots up later. Okay. Second question, what factors is the order of the LSP dependent on? The topology, booted up router, and alphabetical order. Three are the main factors order of the LSP dependent on. The second section, the solution RSVP LSP priority levels. We can define the priority value when we create RSVP LSP. Okay. This is the acronym or terminology, the solution LSP priorities. So I need to configure LSP priorities. Okay. So say here the previous two path that is creating in router 1 to router 5, and another path that is blow path that is going from router 1 to router 10. Okay. So all are in 1 Gbps link. So see here, top links used router 1 to router 5 use the available bandwidth is 600 Mbps. Bottom links, the router 1 to router 10 only 400 Mbps available. That is total is 1 Gbps link. If we take 600 Mbps, left will be 400 Mbps. That is very simple. The bin packing problem. When you pack things, the order matters. Imagine packing three suitcases for a holiday. This is an example, right? Correct strategy. Pack the big things first. Spread your big items among suitcases. Small things fill it in the gaps. That means when you create LSP, the bandwidth bigger bandwidth volume reservation will be faster than lower will be the next. Okay. When you create the LSP, that is the example just to showing for understanding. Bin packing is the same example. How can you resolve the problems of LSP priorities? Using RSVP that offers the ability to configure certain LSP are more important than other LSP. Okay, you were just want to prioritize someone or some LSP. Second question is identify the sequence of reserving the bandwidth for RSVP level switch path using the bin packing method. So there is multiple steps. First step is tag your higher bandwidth LSP to be higher priority. Second one is larger LSP can force smaller LSP to calculate a different path. And number three is the smaller LSP fit in the gaps. Number three and number four is priority system automatically moves the smaller LSP to another path in the network. This is automatically happened. Okay. RSVP LSP setup and hold priorities. There is two different priorities. Value number one is setup priorities. Another one is hold priorities. So LSP priority levels. What is the LSP priority levels? So we're discussing the LSP priority levels. LSP priority levels is starting from 0 to 7. 0 means best priority and 7 means worst priority. For both, that means setup and hold priorities, we are using the same value 0 to 7. Okay. So setup priority and second one is to hold priority, setup and hold priorities. When you're checking LSP, just the operational command is show MPLS LSP name, the LSP name detail. You will get the priority value. The default priority value is 70. 7 is the setup priority and 0 is the hold priority. Okay. So this is one example, but configuring the setup priority and hold priority for multiple LSP. The same example. Setup and hold priority. So the question and answer section, what happens when the base path cannot offer enough bandwidth? Cannot offer enough bandwidth. High priority LSP ports low priority LSP to find a new path. High priority LSP are signal fast. And this is the reason for offer enough bandwidth. What happens when the base path cannot offer enough bandwidth? That is a high priority LSP force low priority LSP to find a new path. Low priority LSP will tear down completely if there is no enough bandwidth anywhere. Okay, so this is the duplicate question. I'll delete this one. Number two. Question two, when are the RSVP priority levels important? A box has many LSP and the base path cannot offer enough bandwidth. This is the two reason. However, setup priority and hold priority used to take new LSP setup priority. So RSVP priority levels configuration, how to configure setup and hold priority. The default priority value is 7 and this is the setup priority and hold priority is 0, that is default value. So you can modify this one. How to modify this? Set protocol MPLS, the LSP name, level switch path name, priority, and the priority value. First one is setup, and second one is hold priority. Okay, we'll get the priority value. Set group RSVP, LSP priority protocols, MPLS level switch path. If you configure for all LSP, you can configure groups, configure groups for setting the setup and hold priority. You can use this. Okay. So this is the verification command when you setting group. If you want to check if this configuration is in under group, so the verification command is display inheritance. Then show you the actual configuration. Okay. Which statement is used to change all LSP priorities? That is apply groups. Okay. Which statement used to visually confirm the apply group config. Display inheritance is the command to verify apply group details configuration. RSVP priority levels verification. After configuring, you need to verify the RSVP priority levels. So how to verify the RSVP priority level? The command is, this is the command configuration verification, show configuration protocol MPLS. Then you can see the LSP name under LSP for setting the priority value. And the verification command is pressing the operational, going to the operational mode and press the command show MPLS LSP name, the LSP name detail. You will see the priorities level. Okay. So show MPLS LSP name, then LSP name extensive. Also, you will get the priority value. So the question answer section, what happens to the existing LSP if you configure a third LSP to see the priority system in action? The new LSP kicks the existing LSP off its path. Okay, this is the normal action. Avoiding downtime with sub-preemption. Avoiding downtime with sub-preemption. Basically, when you configure sub-preemption in under LSP, that will make that is you can call make before break. Make before break when you configure sub-preemption. Okay, so consider there is two path. One path is primary, another path is secondary. When you configure some sub-preemption, if primary goes down, secondary will be immediately up. When you configure sub-preemption, this is you can say auto failover or switchover that is taking very much little time around countdown after 30 seconds. So sub-preemption in action, when you configure the sub-preemption, this is the verification command. You will get the message like this, a reroute request due to sub-preemption received. This will take little bit time to switch over from primary LSP to secondary LSP. That's why we configure sub-preemption under MPLS LSP. Okay, so we see now question and answer section, which statement is used to enable an LSP to be preempted with a gentler approach, that is sub-preemption. Which option can you use to avoid preemption downtime? The adaptive statement, preemption downtime, and the sub-preemption statement both will be used to quickly switch over from primary path to secondary path when primary path goes down. And the LSP bandit priority, this is the lab. So our slide now finished, and now we're going to check our lab. So there is two things. So one thing is priority, another one is adaptive and suppression. How do I enable this one? How to configure this one? How to verify? Okay. So edit protocol MPLS, then CU. One LSP is under MPLS protocol. The LSP name is BMX1 to BMX5. There is no priority value here. So check this one. Run show MPLS LSP. The name MPLS LSP name is this one. And the command is detail or extensive. You will get the priority value details. This is the primary path, and the primary path is priority is 70. This is default value. This is basically a default value, and the bandwidth reservation is happened here. 400 Mbps. 400 Mbps. That means bandwidth reservation. Yes, bandwidth reservation is happened here. And another one is the preemption. No, preemption is configured here, I think. No, no preemption is configured here. So first we configure and the priority. How to configure the priority? Set level switch path. The level switch path name is PMX1 to PMX5. Then setting the priority. This is priority value. Then first one is setup priority. The setup priority range is 0 to 7. 0 is best and 7 is worst. Okay, so you can configure the priority value. I just configure here like 3, and a reservation priority, that is starting from 0, and 7 is worst, 0 is best. So configure the reservation priorities too. So we are configuring setup priority and the holding priority. Setup priority all time is greater than the reservation priority or holding priority. Okay, so need to check our configuration verification. Yes, priority change is done. Now we configure another command, that is subpreemption. Subpreemption. Subpreemption is attempt make before break. Make before break. Before break, your LSP will create when you apply the subpreemption. When you are applying the subpreemption. And another option is adaptive. Have the LSP smoothly cut over to a new routes. That is another option. That is, you need to configure adaptive, and another one is subpreemption. So say this one and come and check the configuration. The configuration is okay. Done. So we're doing three configurations today. Number one is priority, another one is adaptive, and last one is subpreemption. So check the verification, yes. Subpreempt, subpreempt is enabled. Our priority value is setting. So your subpreemption is enabled here, and you are configured the adaptive. That means adaptive means they just smoothly switch over from primary LSP to secondary LSP, and subpreemption attempt to make the secondary path first, secondary path first before break. Before break, they're making the alternative path. So these are very useful commands to prioritize and optimize LSP. Prioritize and optimize the LSP path. Okay. So I think you can configure LSP priorities and optimization of LSP. So that's all for today. We'll discuss next section or next module in next class. Our next class we will discuss modules 10, RSVP constant, shortest path first groups, shortest path first and admin groups. Okay. So that's all for today. Thank you. Allah Hafiz.